Hello, welcome back. Yet another example of an application. I'm taking varied applications just to show you, give you a glimpse of how useful maths is in every other discipline, or every other subject or subject area. For example, now people have studied forest fires. Every summer you see on the TV in Australia, in Canada, in India, in Europe, forest fires. They're the most destructive. So, in established forest fires, the proportion of the total area of the forest, proportion is a fraction of the total area of the forest destroyed is X, and the rate of change of X in T hours is the destruction rate. So, rate of change is dx by dt. The destruction rate is proportional to the product of X and 1 minus X. So, in other words, T equal to T hours, and then X is equal to area destroyed, fraction of area destroyed. So, it's proportional to X times 1 minus X, or dx by dt equals kx times 1 minus X. Now, I put a positive k because X is the area destroyed. So, as time goes on, the area destroyed increases. That's why I put a plus k. This is the interesting part. A certain forest fire was first noticed when half its area was destroyed. So, T equal to 0, X equal to half. So, what is dx by dt? Dx by dt is k times half times 1 minus half, or k over 4. The rate of destruction at that time was such that if it remained constant, remember it doesn't remain constant because it depends upon X and 1 minus X, the product, it keeps on changing as X keeps on changing. But suppose for a moment it was a constant, then the whole forest would have been destroyed in the next 24 hours. That means in the next 24 hours, half the forest would be destroyed. So, in other words, time 24 hours, area is half. So, therefore, the rate, what would be the rate? Rate is half over 24 is k over 4. So, 1 over 48 is k over 4. So, k is 1 over 12. In other words, you are assuming what if it were to be a constant? The constant rate based on when it was discovered, based on the differential equation is k over 4. If the rate is constant, the rate is change in area over change in time. Change in area is half, change in time is 24, so it's half over 24 is the rate. And that should be equal to k over 4, so k is 1 over 12. So dx by dt is 1 over 12x times 1 minus x, or 12 dx by dt equal to x times 1 minus x. You're asked to show that. This part carries, this is from a very old textbook, which I used to refer, I used it as a classroom textbook way back in the 1970s up to about 1982-83. And that's where I picked this question from. It could have been from a past paper way back in the 70s, I don't know. I remember this question distinctly because it's a beautiful question to solve and a challenging question. So now we have proved it. Would you have thought of it? Oh my, it's wonderful. So dx by dt, 12 dx by dt is x times 1 minus x. Again, in the exam, if a similar question comes, you do not know how to do all this. Too confusing. Don't bother. You lose the mark for that, but from there, you can solve the question. Separate the variables, 12 over x times 1 minus x dx equal to k is equal to dt. I would keep the 12 1 over 12 here to make life easy. So, okay, I can't integrate directly. It's a fraction. A proper rational expression because the numerator has less power than the denominator. Yeah, I thought it was not recording. Okay. And then when I differentiate the denominator, I get 1 minus 2x. I don't have it in the numerator. So partial fractions. So let's do it here. 1 over x times 1 minus x is a over x plus b over 1 minus x. So 1 equal to a times 1 minus x plus bx. X equal to 0, a equal to 1, x equal to 1, b equal to 1. So it's 1 over x plus 1 over 1 minus x is 1 over 12 dx. Integrate ln x plus ln 1 minus x over minus 1. Or when you differentiate 1 minus x, I get minus 1. So I'll put this as a minus and put a minus there. The numerator is the exact derivative of denominator. So it is ln denominator equal to 1 over 12t plus ln a. So ln x minus ln 1 minus x minus ln a equals 1 over 12t. So ln x over a times 1 minus x is equal to t over 12. So therefore, x over 1 minus x is a power t over 12. Let's make x the subject. It's easier that way. So x is equal to, t equal to 0, x is equal to half. So half over half is a power 0, so a is 1. So once I got that, I can remove all this because I'm still solving the differential equation. So therefore, my final solution will be x over 1 minus x equals e power t over 12. Make x the subject. X is equal to e power t over 12 minus x e power t over 12. So x times 1 plus e power t over 12 equals e power t over 12. So x equal to e power t over 12 by 1 plus e power t over 12. You might be wondering, why am I doing this? I'll tell you why. I could straight away put t as 12 hours. Excuse me. And then find x. Or then when I want to find x, I'm going to have a decimal. I'm going to multiply x with a decimal. So to avoid that, and there's a reason why, because I want to deduce something from there. Which is very interesting. Now put t equal to 12. Further 12 hours. So x equal to e over 1 plus e. What is e over 1 plus e? Bum, 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 bum. Shift ln 1 divided by open bracket 1 plus shift ln 1 close bracket close bracket 0.7310. Approximately 73%. In fact, of course, see, you remember the question on surgeon I did. These things are used, but they are not going to sit and solve a differential equation. Some mathematician like you will have solved a standard, if this is room temperature, this is what it is, this is what you should look at. They just put in the values and they've got a table and they use the table. Same way here, forest rangers who monitor forests, they have a standard formula which they use, and then in that they just put the time and estimate when it will be destroyed. and take precautionary measures. Yeah, pretty interesting question, isn't it? There's one more interesting question. I don't know whether how many of you have heard of the snowball effect. Have you heard of it? The snowball effect. I think what I'll do is I'll develop the question as I mentioned. This again is from the same textbook which I was talking of. These were some challenging questions. Imagine this I used to give this as homework to my students way back in Kenya. And of course, when I moved to England, by then the syllabus had changed quite a bit. The questions in the textbooks were not that challenging, but I used to give these for those who are aspiring for A star and for my students, because I wanted them to face the challenge. I hope I have enough time. I might take about 12-13 minutes, so it doesn't matter. Look, the rate at which a snowball gathers mass is proportional to two factors. A, due to gravity, gathers mass is affected by two factors. Due to gravity, gains mass proportional to its mass. Part B, due to rolling, gains mass proportional to its surface area. Okay, these effects can be added. We have to make an assumption. Assume that a spherical snowball. Assume that ball remains spherical and no change in density. Okay. If R is the radius at time t, show that dr by dt equals A plus br. If at t equal to 0, R equals R naught, show R equal to R naught e power kt plus C over k e power kt minus 1. Fortunately, no value is given, so it's more a theoretical question. In fact, it is true. When you look at an avalanche, when you're snowballing, you start with a small ball, as it rolls, it becomes bigger, bigger, bigger. Because, when weight increases, it presses more into snow, so gathers more snow. And the surface area is bigger, so it picks more snow. Makes sense. So let's look at this. So I'm assuming, first and foremost, the rate at which the mass increases is proportional to its mass. So I'm assuming mass m at time t, and radius is r. So can I say dm by dt equal to am, surface area, and also dm by dt is proportional to 4 pi r square. Surface area, surface area. So dm by dt is equal to b times 4 pi r square. Why? Surface area of a sphere is 4 pi r square. The effects can be added. So dm by dt equal to am plus 4b pi r square. Where the hell am I going to get a plus br from? Interesting, yeah? This is where your knowledge of physics comes in. Look, mass equals volume times density. So m equal to v times density is rho, a constant. Don't forget it's a constant. So m equal to rho 4 over 3 pi r cube. Volume of a sphere is 4/3 pi r cube. dm by dt equals dm by dr times dr by dt. So therefore dm by dt equals 4 pi rho over 3 is a constant, 3r squared dr by dt. So if you put it here, I get 4 pi rho over 3 times 3r squared dr by dt equal to a times 4 pi rho over 3 r cube plus 4b pi r squared. Look, I can cancel the 4 pi, I can cancel the 4 pi, I can cancel the 4 pi, I can cancel the 3's. Yeah? So what do I get? So r squared dr by dt, no, dr by dt equal to, let's start from here, a rho r squared over 3 times, I am dividing by rho r squared, 1 over rho r squared plus b r squared, r cube, b r squared times 1 over rho r squared. Rho and rho cancels, r squared and r cube gives you r. So it's a over 3r plus b over rho. A over 3 is a constant, b over rho is a constant. So I can say this, they call it as br, so that's a plus br. Did you ever imagine that you will be asked to do this? Imagine if this question comes in a, I think it is from an old Cambridge paper of 1970s. So if your dad or your granddad, maybe not granddad, maybe dad, maybe granddad too if you are very young, when he or she or grandmom, when they did their A-level, they might have come across this question if they were to be fortunate enough to to be doing A-level at that time. Very interesting, isn't it? Oh my God, I love this. So let's solve this. Of course, people doing further maths know how to do it in the first order linear, but it doesn't have to be first order linear. So I can say 1 over a plus br dr is equal to dt. When you differentiate a plus br, I get b. So 1 over b integral b over a plus br dr is equal to dt. So b ln a plus br is equal to b, I can put here, I can take, let me write this. So integral b over a plus br dr is equal to integral b dt plus ln d. because I want to bring in those things there. So ln A plus BR over D is equal to BT. So A plus BR over D is equal to E power BT. So A plus BR is equal to D E power BT. So BR is equal to D E power BT minus A. So R equal to D over B E power BT minus A over B. Now we keep on changing the constants. Oh my God. I think it's very confusing, yeah? But doesn't matter. So R equal to, I'll write again as a lambda e power kt minus mu. D over B is a constant lambda, A over B is a constant mu. T equal to 0, R equals R naught. So R naught equal to lambda minus mu. Okay. So R equal to, so what will R become now? So R equal to, or mu equal to, what do I want? I want R naught e power kt. So therefore lambda equal to R naught plus mu. So R equal to R naught plus mu e power kt minus mu. That is R naught e power kt plus mu times e power kt minus 1. Mu is C over K, something like that, it doesn't matter. C over K is the constant mu. I think I'll change the question here, put it as mu. What a lovely question. And aren't you thanking your stars? You don't have to do this these days. Well, anyway, that's taken 22 minutes, but it's worth it because I wanted to show you how varied. In fact, you know, there was a question in one of the textbooks on economics. Use differential equations in economics. You use it in physical chemistry, rates of reaction. You use it in population studies. You use it in pandemic growth. COVID, they will have used this. How, you know, they predict by 15th of February, so much population. Therefore, they don't sit and solve a differential equation. Someone, a mathematician like you or I, will have given a standard model. They give a standard model, then we come up with a solution. They apply it. That is what maths is all about. Okay. Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.